The fact that artificial intelligence is very expensive, it uses more and more energy. This energy demands are increasing exponentially, and with FinalSpark, with living computers, we want to solve this problem. We have real living neurons, the same as we have in our brains. We want to build computers from that. We put living neurons on the electrodes. With this way, we try to program living neurons.
Computer follow instructions, and biology is massive and adaptive.
Yes, that's true. In neurons, you have memory and processing in the same place. Neurons are extremely energy efficient.
Hello everyone, welcome back to our podcast. Every time we talk about artificial intelligence, we imagine faster computer, smarter algorithms, and more powerful machines. But what if the future of intelligence doesn't come from the faster chips? What if it comes from biology? Today's episode explores one of the most thought-provoking ideas in modern science, using living human brain cells as part of computing system. My guest today is a scientist from FinalSpark, a Swiss deep tech company based in Vevey. FinalSpark works at the intersection of biology, neuroscience, and computing, exploring how real neurons work. The same type of cells found in human brain can help us rethink how intelligence and efficiency actually work. This is not about building artificial brains. This is not about creating consciousness. It's about learning from nature's most efficient computer, the brain. Before we go deeper, I would love our listeners to hear directly from you. Evelyn, could you please briefly introduce yourself, who you are, what you work on at FinalSpark in your own words?
I'm Evelina Kurtis. I'm neuroscientist by background. I come from Poland. I studied in different countries. I did my PhD in Netherlands, and now I'm living in the UK. After academia, I left to industry and I started to work with startups. I discovered this fascinating world when you can do what you want. You can create your own life with entrepreneurship. So I started to work with small companies, and one of this is FinalSpark, where I am a strategic advisor. And I started to specialize in artificial intelligence when I started to work with startups. So this FinalSpark is perfect project because it is combination of neuroscience. So this is my academic background, and engineering, which is my industry experience.
Okay, interesting. So, just one more thing before we dive in. What originally drew you personally towards this kind of research?
We wanted to solve the problem of the fact that artificial intelligence is very expensive. It uses more and more energy. So that's a huge problem today. And this energy demands are increasing exponentially. And with FinalSpark, with living computers, we want to solve this problem because we want to build computers which will use 1 million times less energy than silicon computer.
Mm-hmm. Interesting. So let's come to FinalSpark especially. So I have a question. When people first hear about FinalSpark, the reaction is often disbelief. Behind all the headlines, curiosity, what problems were you and your team actually tried to solve?
So we try to solve the problem of increasing energy consumption by artificial intelligence. Yes.
Let's clear up the common misunderstanding early. When people hear human brain cells, they imagine something dramatic. What are you actually working with?
So we have real living neurons, the same as we have in our brains. And this is normal thing actually to culture living neurons in the lab. Many laboratories in the world do this for biomedical research. But we do this for special purpose. We want to build computers from that.
Interesting.
This is what we try to do, and we put living neurons on the electrodes. That
Mhm.
means we can send them electrical signals, and we can also measure the response. And with this way, we try to program living neurons. So we want that this input we send them and the output which we get from them, that there will be a relationship between these two signals. And we hope that this will be the beginning of computer.
Interesting, interesting. So, if I had to explain this to non-scientist, I would say traditional computer follow instructions while biology responds to experience. Would it be a bit same to say that what this technology is actually doing?
No, the technology, well, we try to build computers with living neurons. So you can go to our website, finalspark.com. There is section live where you can see how this looks actually in the real world. And as mentioned, we try to send electrical signals and try to measure response from neurons. And we want to be able to program them so that they can perform tasks as digital computers today.
Okay, interesting. Traditional computers are precise and predictable, and biology is massive and adaptive.
Yes, that's true.
Why that messiness is valuable?
Well, maybe it's not a messiness, but what is valuable, neurons are processing and encoding information in totally different way than digital. So neurons are working in time and space. So it matters when and where in the brain neurons are active. And also there is a lot of differences. For example, in neurons, you have memory and processing in the same place, while in the computer you need a separate unit for processing and for memory. And all these differences are the reason also why neurons are so efficient. So what is important here that neurons are extremely energy efficient compared to the silicon.
Interesting. One of the most fascinating things FinalSpark has built remote access to these biological systems. Why was that important?
Started in COVID because our researchers wanted to continue to work and they couldn't go to the lab. So that's why they developed everything remote. But later we decided to use this opportunity and invite universities to work with us. We first gave free access to selected universities. From 34 projects, we selected 9 and we gave free access to them. Of course, in exchange to the promise that they will publish something scientific in the scientific paper. And now we are very happy because we have also users from industry, from academia, private people, startups, and big companies who pay us to get access and to try to do fundamental research on biocomputing.
Interesting to know. So it's already in use with the
Yes,
with several several companies or education or biotech companies. They are
yes,
already
yes.
using it. That's interesting. I would have some other questions about the ethics and the responsibility, since when we are talking about artificial intelligence, calculation, processor, all these things. So my question is, whenever biology and technology intersect, the ethical question naturally arise. How do you approach that responsibly?
Which responsibility?
Ethics and responsibility, basically, in the semiconductor world, when we are seeing how artificial intelligence is being developed. So it's
Mhm.
basically understanding the text, and now all rules, regulations, and ethics are coming that people are not harming or not using it for the wrong sense. So if we try to apply on the same thing with this kind of intelligence which we are trying to develop within Final Spark, or this
Mhm.
kind of processing engine, then how you take this ethics and responsibility part? Or is this something which crosses your mind even? Or maybe my question might be wrong.
Well, there are a lot of ethical questions, which are, I think, the same for digital or biology. And there are also some questions which are specific only for biology, because we are working with living neurons. We got actually some questions from the public because project is more and more popular. So of course, all kind of people check it, not only researchers, not only scientists, but also general public. And what we did, we actually realized that we are not philosophers. So we are not really competent to answer all these questions. And we reach out to philosophers, to real philosophers, to promote this topic among them and encourage them to do research, philosophical research on biocomputing.
Okay, so probably Noel Yuval Harari might be looking after this, and he might be
We
posing
haven't
some questions.
talked with him. We haven't talked with him, but similar people, yes, definitely. We'll look at this.
Energy consumption is becoming a global concern in general, AIs. So, how serious is this problem from your perspective? And of course, a Final Spark is one of the solution which is going to solve this problem.
I think that artificial intelligence has a huge scalability problem because we need more and more energy to run this. And I think we don't feel this problem today because the prices of many AI models are lowered to ensure adoption. And in reality, it costs much, much more, and we don't see this yet. And I also think that another very big problem of AI is how to make sure the alignment, we have alignment, so that AI will always be on our side. I think these are the two most important problems with artificial intelligence: how to make it cheaper and how to make sure that it will always benefit us, not harm us. And I think for the first problem, we solve it with the FinalSpark bioserver. And the second problem is generic. So it doesn't matter if the AI will be on silicon or living neurons, we still have it, and we have to make sure that it's built in such a way that it benefit us, not harm.
Interesting, interesting. So let's move towards looking to the future. People often ask when this kind of technology will become useful. How do you usually respond?
We have a timeline, very specific, around 10 years, assuming we will find an investor, because currently we are self-funded, so we are very small team, very limited funds, but we are currently seeking 50 million Swiss francs investment. And we expect that with this investment, we can build biocomputer in 10 years. But we also expect it will be very profitable. And we forecast billions of revenue, of profit also, once the biocomputer is working in around
Okay,
10
and
years.
in around 10 years. Interesting, interesting. So, are there any competitors in this field when you see
Yes, we have biggest competitor is Cortical Labs in Australia.
Australia? Interesting. So, I would say the impact is more conceptual of this neuron based computing than its commercialization, because I mean, commercialization timeline you are expecting around 10 years.
Yes.
So at this moment, I mean, when you guys are building this company, so I was reading it's inside the Swiss. So your operations, all operations inside the Switzerland, or it's going across other countries as well?
No, we are based in Switzerland. Mhm.
Okay, we have gone through all. I mean, a few questions which will highlight the value of this kind of technology, how it will prosper, how it will remove the challenges of the energy, and the fundamental change of how data is processed, processing,
Mhm.
and the memory is all together. That seems quite promising. So, with this, I would say, listening to you, what strikes me most is humility. For decades, we believed intelligence was something we could fully engineer, and Final Spark suggests that intelligence might be something we need to observe, respect, and learn from. This is not about machine becoming human, it's about humans learning from nature. Thank you for taking us into this fascinating frontier. Thank you. Curiosity is where all this begins. Okay, bye bye.